Good morning to one and all. Today we are going to discuss about the practicals actually. So electrical measurement and instrumentation practical we are going to discuss. Already we have discussed one practical, that is the Megger. About the Megger we have already discussed. And the next experiment is that is measurement of power in three-phase circuit by 2 wattmeter method for balanced load here. So for the three-phase circuit, it may be star load or delta load. Okay, three-phase means each phase one load we are going to add. It may be resistive load, inductive, or combination of resistive and inductive load. If all three phases load distributed to all three phases is same, then that is called balanced load we are going to call. That is called balanced. If further, suppose three phases are there here, three phases. Okay, so the load connected to this phase is different, load connected to this phase is different, load connected to this phase is different. That is called unbalanced load. We are going to call that one. Okay, so we know the power formula for the power. What is the power formula for the power? We know that one, VI cos phi. Yes, we know the power for VI cos phi is the actual formula. Single phase or AC formula we are going to consider here. But how many for each phase here? 1 wattmeter we have to connect to measure this power, phase power, this phase power. But instead of 3 wattmeters, by using 2 wattmeter also, it is possible to measure the power. For that reason only, measurement of power in three-phase circuit by 2 wattmeter method only. By using only 2 wattmeter method, we can calculate the total power, three-phase power of the circuit for balanced and unbalanced load also we are going to discuss here. So that is how we are going to do here now. Yes, already in the kit I have shown the connection and we have run the motor and we have already taken the readings. Today we are going to discuss only on virtual lab. On virtual lab, how it is going to operate for the balanced load and unbalanced load. I am going to show that one. So this is the title. The main aim of this experiment is to measure three-phase power using 2 wattmeter method for balanced load here. Now, whatever the title is there, same, but to measure, we have to add here. To measure, aim is to measure the power, three-phase power we have to measure by using only 2 wattmeters here. That is the main aim we are going to call that one. So next, aim apparatus procedure. Before discussing the procedure, this is the circuit diagram we are going to discuss here. This is the circuit diagram here. See here, this is the RYB. 3 lines are there here now. So this is the three-phase supply we are going to call that one here. Three-phase supply. Suppose pole mounted transformer, say this one, it came to your houses or our laboratory. Whatever, by providing one socket here now, here the MCB 3 lines, it came here now. 3 MCBs we are going to use here now. Okay, three-phase supplies came to here. For each phase, this is R, this is B and Y. Like that, 3 phases supply came here. Once it came, I will provide the switch here now. This is the switch here now. We have used one switch that is called TPST. Can anyone tell the long form of this TPST? Yes. TPST. Yes. Means what? Anyone, can you tell me? Is it audible or not? I have unmuted or not? Yes, unmuted. Is it audible? All of you? Reply fast.
Yes, sir.
Okay. Then, see here, I will tell that one here now. What is this one? This is the pole we are going to call here. This one, it is a pole. Switch means When this pole, it will joins to this one, it will become switch is closed. If it is open here, no, so switch is open here. So this one is pole, whatever the dotted line is there, it is a connection, it is going to joint at this point. If this point and these two are jointed, means switch is closed. It is, they both are not joined, then we can call that one as open here. So this, whatever this one is there, moving part, that is called pole, we are going to call here. Pole, we are going to call that one here. So it will only move to one side only, this side only. It is not possible, suppose the switches will be like this, here the pole is there, it is 2 points we are going to provide here now. This may be joined to here, and also it may join to like this, we can join to this point also, like that switches also there. But here only one way it is we are going to use here now. So pole, this one we are going to pole. How many poles are there? 1, 2, 3. Yes. How many poles are there?
3.
3 poles. This T is nothing but 3. P is nothing but poles. Triple pole we are going to call that one. How many poles are there? Triple. Three are there, no? So for that reason, triple pole. This S indicates one way close here now. One way is nothing but single through. This one through we are going to call single through, and total this process is called switching process. So switch we are going to call here. Triple pole, single through, switch here. Is it clear? Triple pole, single through, switch. Is it clear?
Yes, sir.
Okay. So once the supply, this one we have to do the connection from this switch only, this switches only. So what we will do here, this is the circuit diagram. From this point, what are the main components? We will do that one. Here the TPST we have used here. No, what is the this one? Ampere is nothing but here we are using some 10 ampere MCB circuit breakers we are using here. No. These are the circuit breakers we are going to call that one. For each phase, one circuit breakers we have used. What it indicates? This one. What is this one?
Ammeter.
Ammeter. Which one? AC or DC?
AC.
AC. This sinusoidal wave indicates AC. If only straight line is there, means that is called DC. So here one ammeter is required. The rating of that ammeter is 0 to 10 ampere. 10 ampere ka ek ammeter, one ammeter is required here. Now that is EMI. They have written EMI is nothing but moving iron instrument here. Okay. So 10 ammeter rating, 1 volt ammeter we have used, 10 amps rating, 1 ammeter we have used here now. And this one here, actually it is a watt meter here now. This is current coil and potential coils we are going to use here now. So this process we'll discuss in the electrodynamometer. When the electrodynamometer will discuss, on that situation they will come. This round circle, it indicates watt meter here now, 1 watt meter. It has 4 terminals here now. One is M, L, C, V. M, L, C, V. 4 terminals are there. Based on connecting these diagrams and all the things, already have shown in the last class also. The real watt meter also I have shown here. This indicates watt meter here. Okay. How many watt meters we are using here now? 2 watt meters. And this one is 3-phase variable resistive load we are going to use. Only resistive load they have used here now. So this is the load we are going to call. This load is connected in star or delta. Anyone, can you tell me? It is connected in star or delta? Star. It is connected in star. Yes.
Yes.
So it is a star connected load we have used here. So the unity power factor, the watt meter rating is up to 600 volt, 10 ampere. UFF, it indicates that unity power factor here now. These are the main components. Ammeter is required, watt meter is required, connecting wire from here to here we have to do the connection, this to here, the load is required. One voltmeter also we have to use here now. For the balanced load, all the voltages, line to line voltage, nothing but line voltage we are going to call here. This is the voltmeter we have to use, that is 0 to 600 volt voltmeters we can use here now. 0 to 600 voltmeter we can use here. So this is the circuit diagram. By seeing this circuit diagram, we have to decide what are the components are required here now. These are the components are required. 3-phase balanced load चाहिए हमको, resistive load 1 चाहिए quantity. Okay. Second one, wattmeter, dynamometer type, 500 volt or 600 volt, 10 ampere. That is how many wattmeters are required? Wattmeters कितना चाहिए?
2.
2 wattmeters. 1 voltmeter is required. 1 voltmeter we have written. Actually, they have written 2 here now. Moving iron emitter is required 1. And connecting wires are required. Some बोल के लिखने के इधर. And 3-phase variac. 3-phase variac means 3-phase variable voltage source we have to use. That is at the starting only we have to use here now. Variac we are going to call that one. 0 to 440 volt we can vary that one here. Variac we are going to, whatever we have used in the practical, physical practical live when I have shown, and that situation we have used here. And this is the observation table or tabular column we are going to call. The serial name, serial number we have to write. Emitter reading, that indicates line current. Voltmeter reading लिखने का. Total power means by using this emitter and voltmeter we have to calculate by using this formula, and calculated value you have to write here. And 2 wattmeters we are using in the circuit diagram. Wattmeter 1 reading, wattmeter 2 reading, and the total power by using wattmeter 1 plus wattmeter 2 we have to write here. So this is, later we'll discuss for the procedure. This one, what we have to do according to this circuit diagram, here one emitter is there, that is line current we are going to call. Emitter place mein we have to write that one. Here we are using 1 voltmeter, that voltmeter reading we have to write in the voltage line. Wattmeter 1, wattmeter 2 we have to write both the values in the this table here. Here emitter reading, here voltmeter reading, here wattmeter 1, wattmeter 2 reading. Later we can calculate by using this formula. We have to IL, VL we have calculated. This root 3 is already a constant, and cos phi is unity power factor is there. 1 we can add that one here. So you can calculate this power here. This power should be equal to this power. W1 plus W2 should be equal to this 3-phase power here. That is, we have to show that one here. Verification. So next procedure we have to do. We know the connection circuit diagram, we know that one. Based on that circuit diagram, we have to make the connection as shown in the diagram. First procedure is make the connections as shown in the diagram. We have to do the connection. Later, the readings of W1 is nothing but wattmeter 1, wattmeter 2, V phase, I phase is nothing but voltage, current are noted down in the observation table. Observation table में हमने लिख देने का. Next, then calculate the total power using both equations mentioned below. P equal to W1 plus W2 and P equal to, this is 3 V phase, I phase. Phase voltage they have used here now. For that reason, 3 we are going to use here. Instead of this V phase, we can use V phase equal to VL by root 3. Yes. V phase equal to VL by root 3. So VL by 3 divided by root 3 is nothing but 1 root 3 will be root 3 VL IL. I phase equal to IL for the star connection here now. So that formula also we can use here. Now write down the readings in the observation table. We have to write the reading in the observation table here. So the formula, all of you know that one. For the phase to line, how we have to convert the formulas, you have to know that one. We are by using 2 wattmeters, we are using is 2 wattmeter. Directly the power it is going to measure here now, but for each phase it is going to measure by observing 2 phase only, calculating, which will give the full power, 3 phase total power it is going to give. To verifying purpose, we are going to calculate by using P equal to 3 for the single phase, V phase into I phase we are going to call VI. The cos phi we are considering as 1 here. But for the 3 phase, 3 V phase, I phase, they have written here now. But the actual formula we can write like this also. Root 3 VL IL also we can write cos phi equal to 1. We can write here now. For the unity power factor, we are going to call cos phi equal to 1. For this value only, we are going to calculate here. In the observation table, this one only we have written here now. That is the theory part. We can call that. See here, observation table, we have written this formula. Yes. So this is the theory procedure, and we have discussed the experiment here. Next, we'll go for the what we'll do. We'll do this experiment in the virtual lab. Already the live session is shown in the last practical only. Last practical, all of you have seen the live session. So the connection is not that the what is that one when the physically you are doing means that is different. The showing the live session is different. So what we will do, the last class also I have done that one, but some people's because of the time lagging, we have discontinued that one. So we'll completely explain today's lab. It will be on virtual lab. Okay, step by step I will tell that one how to open the virtual lab, where we have will get the experiment, measurement experiment. You can try in your houses also. Okay, theory part, is it clear?
Yes, sir.
For the
Yes,
balanced
sir.
load means this resistance, this value, this value, this value, all three values of the load will keep same only. For unbalanced load means this is 100, this is 200, 300, like that we have to set separately values. We can set that one. That is balanced and unbalanced. We are going to call that one here. Is it visible? Screen is visible?
Yes, sir.
What you have to do in the this search URL is there. Here you just write vlab.co.in, vlab.co.in. Is it visible? vlab.co.in. Is it visible or not? Here I am writing here now. Have written already. Yes.
Yes, sir.
Okay. Just enter that one here. Once it is entered, it will get open the virtual lab here now. A initiative of Ministry of Education, actually. The Education Minister, he has opened this one here now under National Mission on Education through ICT content, actually. Internet content through, we can do that one here now. So you can read these all the things, or directly you can scroll down. By scrolling down, what are the objectives of this, the broad areas of virtual labs here. These are the broad areas. We'll get that one. Electronics and communications, computer science and engineering, electrical engineering, mechanical engineering, chemical engineering, biotechnology, civil, physical science, chemical, all the places will get that one. See here, actually you are studying in electrical engineering, but in this university they have made the subject for electrical, but all other universities the measurement and instrumentation subject is actually it is an electronic subject. So I will check that one. I will click on this one. If you will get the experiment subject is there or not, you can check that one. Is there any measurement is there or not, you can check that one. Virtual lab for simulation, gaming, automation, virtual power lab, drives lab, like that only there. You anywhere you are finding the measurement, you can check that one. Is there any measurement word? No. So instead of searching this, I told that one actually the electrical measurement and instrumentation, that is electronic subject actually. So you can go for the electronics and communication subject here now. Click on that one. See here, the channels and communication lab here. Analog signals, networks and measurement lab. It is there. Here it is there. This part. The subject is there, measurement lab. Yes or no?
Yes, sir.
Analog signals, network, and measurement lab. Here it is there, which is designed by the IIT Kharagpur here. They have developed this virtual lab here. What we have to do? Nothing to do here. Just click on this analog signals and network simulation lab. So next, here the virtual home page, it will come, it will give the introduction of the subject, a basic electrical technology laboratory. They have given here now some signals and network laboratory, measurement laboratory here. Okay, in this laboratory, student will get explore and learn various concepts regarding the analog electrical signals. I think ADIC, the next semester, you will get one subject, that is analog circuits and digital circuits. That is, for that reason, analog electrical signals, networks, measurement of various electrical components. So some basic technology, basic experiment also for both AC and DC, you can do that here. Now, just it is a introduction of this subject, or well, analog signals, network, and measurement of virtual lab introduction. It is part. Okay, our aim is to, we have to check our experiment is there or not here. Here the list of experiment is visible, this area. See here, this is the list of experiment. First the introduction part, this one, the introduction part they have given here. Now list of experiment, on that we have to click on that one here. So the downside, it is showing the list of experiment. A basic electrical technology for UG students of all disciplines. This is basic electrical engineering. All the details are available here. I think the network analysis subject will also come in the next year. No, sorry, next semester. Norton's theorem, Thevenin's theorem, intelligence, superposition theorem, Milliman's theorem. Here, see here, three-phase power measurement. It is there. Three-phase power measurement. See here. At this point, three-phase power measurement. All of you are seeing or not?
Yes, sir.
This is the three-phase power measurement. We are going to do the discussion of this experiment. We will do here. And next, other than this, let's single-phase transformer also. The single-phase transformer you can do. Verifications of compensation theorems you can do. Some signals verification you can do. Maximum power transfer theorem, reciprocity theorem, all the things we are going to do here. RL circuit, RLC circuit, and all. See here, next in the, that is actually we got in the basic electrical subject. See here, measurement laboratory for UG students of EE, EC, and instrumentation engineering. Actually, IN is that. These are the experiments are there. These all experiments are there in the third unit. Third and fourth unit is there. For that reason, I am not going here now. Once the third unit we have started, means all the bridges, potentiometers are there. All the bridges we are going to do by virtual lab here. It will take another 1 week, I think. After 1 week, we'll start this one. Okay. So ours is now, which experiment we have to do? Three-phase power measurement. Just click on this three-phase power measurement. It will open the experiment here now. The experiment phase, which is three-phase power measurement page, it is going to open. First, they will give the theory part here now. Here the theory, that theory is explained here. The main objective of this experiment is three-phase power measurement by 2 wattmeter method. Here the load is there. Actually, resistive and inductive load they have combined, they have used here. 1 wattmeter is connected to the first phase, another wattmeter is connected, and third one is shorted here. Third one is shorted at the one terminal of the wattmeter here. So that is main objective is to measure the three-phase power by using only 2 wattmeters. That is main objective here. Now they have given some theory here. Now W watt is nothing but power is nothing but I Rn. Rn is R phase to neutral and V R phase to neutral plus I Y phase to neutral. So sole derivation, whatever the power derivation is there for the three phase, they have given here. All complete theory they have written here. Already whatever I have explained in a simple word, that is. So here one more procedure is there. What procedure? It is nothing but virtual lab procedure we are going to call here. Virtual lab procedure here. See here, this is the actual circuit diagram. The 110 volt 3-phase 50 hertz 3-phase supply is there here. This is the 3-phase supply. Here the TPST switch they have used. Here the fuses 3-phase for each phase. One fuse they have used here. Now the voltmeter is connected in between two phases. That is called line voltage we are going to call here now. And emitters, three emitters they have connected. Only one emitter is enough, I think. Because for the star connected load, IL equal to I phase. Yes or no?
Yes, sir.
Okay. IL equal to I phase. For that reason, no need to calculate all the phase currents here. Now, only one is enough here now, but they have taken all three emitters here now. And two wattmeters they have connected here now, MLCV, and VV is shorted with the third phase, it is shorted here. All the phases and another two phases are connected through a wattmeter here. This is a star connected load. One end is connected to the phase, another end is shorted with the other loads here. So this one we can call as neutral point. We are going to call that. So this is the circuit diagram. Okay. Next, connect the circuit as shown in the figure. According to this, we have to do the connection. Next, adjust the ganged rheostat for maximum resistance here. Now, ganged rheostat means this indicates that variable value. If it is connected to this point, means it is fixed one. 0 to maximum, we can use that one. Suppose 100 ohm resistance is there, means 100 ohm resistance. It has two terminals here and here, like this. Yes, this one I will connect to here, another one I will connect to here, means it is complete 100 ohm we have used here. Instead of this, I want to use variable resistance, means what I will do, instead of connecting here, I will connect here now, somewhere. Tapping system we are going to call. We can vary this one anywhere at this point here. This is the tapping or variable resistance or variable load type we are going to call that. For that reason only they told adjust ganged rheostat for the maximum resistance. Ganged rheostat, one resistance vary kiya to all resistance will be vary here now, because it is a balanced load we are using here. We have to set the value of load here now. Next, switch on the supply. By closing this switch, we have to switch on the supply, or main supply we have to switch on, where from the board you can switch on that one. After that one, close switch S1. Here the switch is there, we have to close this one here now. Close this one. Next, read the meters to obtain line voltage, line currents or phase currents. These three currents they have given here now. Note down the reading of wattmeter 1, wattmeter 2. You have to note down that one. Note down that one. Next one. Note the multiplying factor in wattmeters also. They have a connection diagram is there here now. Where is the load resistance and obtain at least 5 sets of observation. The current should not exceed the limit of 4.1 ampere. Here the load resistance is 4.1 ampere is there. So more than rated current is this one only. More than that we should not give that one. And we have to vary the resistance load and we have to note down the power. That is called for the balanced load we are going to call. Suppose for the unbalanced load, all the connection is same only. But only thing is that here we can individually we can vary the resistance of this one, vary the load of this one, vary the load of this one. Here the line voltage we have calculated, but the phase voltage is required here now. This R phase voltage, B phase voltage, Y phase voltage, like that here now. So one more voltmeter we have to connect for the load side here now. So V phase, I phase, V phase, I phase, V phase, I phase. By doing this one, we can calculate the total 3-phase power. We can calculate here now for each page here. Because the unbalanced load we are applying here now. This phase 1 power is different, phase 2 power is different, phase 3 power is different. So for that reason, so this all 3-phase power should equal to the wattmeter 1 and wattmeter 2 reading. It should have to equal that one. Other procedure is same only. Only the different load for each low phase load we have to apply different here. Is it clear? Up to here, any doubts here? You can ask any doubts if you have any doubts. This is the procedure of virtual lab or practical also. Any doubts here?
No, sir.
Okay. Next, what we'll do, we'll go for direct simulator. We'll execute the practical here now. The simulator, the prerequisite to run simulator is nothing but the simulator for this experiment designed based on JavaScript platform with HTML canvas scrapping. So users are recommended to use the browser with HTML compatible, means Google Chrome. You can use that one here now. Here, link to the simulator is nothing but click here to perform the experiment. I want to perform the experiment now, so I will click on this one. It will open the experiment here. See here, this is the diagram they have used here. Here, the three-phase supply, they have given 100 volt, 50 hertz. We can vary this one. See here, we can vary 150 also, we can give here. Instead of that 150, we can enter here 150 volts. Yes, the switch is used here now, and the fuses are there here. Fuses already, the fuse, whenever the overcurrent will be happened, it will strips over there. And here 1 voltmeter for the line voltage, it will measure, and watt emitter they have used here now, 1, 2 emitters, and the third emitter also they have connected here now. So that will give the line current or phase current. Both are same one here. See here, this is the wattmeter. It is going to display the wattmeter value here now. Wattmeter 1 value and wattmeter 2 value, it is going to display here. So variable resistance we have used here now. Here 1, 2, 3, and other terminals are shorted here now. So R1 equal to R2 equal to R3. Anywhere we can give this resistance value. I will give 30 here. Is it clear? I'll give 30. There is no current and voltage at all because the switch is closed here now. Main supply is off here. So here, the beside of this circuit diagram, they have given some procedure also. They have given procedure to run this practically here now. How to run that one? First, they told set the three-phase line to line voltage 100 volt at frequency 50 hertz. I will set here 150 set kiya tha, I will set 100 volt. Okay. Next, set the balanced load value. How much? Anything I have set it 30 rehne do. Okay. Next, switch on the supply to get the meter readings and click on fill the table button to update the observation table. They have given the observation table also downside here now. This is the serial number, first reading, second reading. VRY is nothing but line voltage. This one, IR, phase currents here now, IR, and cos VRY, this is the power factor they have used here now. And this is VBY, this voltage, and IB. For each phase voltage, phase current they have used here now. This voltage also here also 1 voltmeter, and emitter they have used here now, and power factor they have used, and I3 ampere they have. I3 is nothing but this one they have connected here now, ammeter, and W1, W2 wattmeter calculated value, calculated power they have written here now. Measured value is nothing but W1 plus W2, and by using the formula of V phase, I phase 3 into 3, that is called the calculated power we are going to. Both these two tables should be same here now. We'll switch on the power supply now. We'll check the reading. See here, I will check. You can check here now. I will write 20 here now. See here, automatically 20, 20, 20, it is changing here. Idhar dekho, this one, and this one, 20. Instead of 20, I will try 25. See here, change it this one. All three phase loads, it is equal. It is showing here now. R1 equal to R2 equal to R3. We'll switch on the power supply now. Can I switch on?
Yes, sir.
Okay, here the switch is there. Just nothing to do over there. Just click on that one. Automatically it will switch us over there. See, the light is blinked here now. The meter is showing here now. See here, the line voltage is 100. How much we have applied here? 100. So 100 it came here. See here, the line current or phase current equal to 2.309 is there. Here also 2.309 is there. So only one emitter is enough according to me. No need to use all the emitters here now. One emitter is enough. We can use that one here. One emitter is enough here. So one emitter reading it is showing. This is the power. Yeah, for the 25 ohm, this is the power we got here. This is the power we got. So what I will do, these all the readings I have to note down. All the readings I have to note down here now. For that reason, what we will do, just Fill the table, you click on this one, automatically all the tables will be filled for the first reading here. Just a minute. Is it visible, complete diagram?
Yes, sir.
Okay. I will click on the fill table. I will click. What will happen? The voltage is clicked here now, shown here now. 100 is there, 100 it came here now. IR equal to 2.3.8 here now. Current, and see here now. W1 plus W2. Anyone, if you have the calculator, you open it and you do the addition of this one here. 199.81 plus 200 plus 0.206 is nothing but 400.02 ho gaye. And the V phase, I phase into 3, that is called 399. It will give here 399 also it is going to give here now. So VL are root 3 into this one also you can do current also. You can do that resistance value also you can do by doing this one also. We'll get the correct value. We are going to get that one by this one is calculated value and this one is measured value by using a watt meter. We are going to call that one. Okay. So suppose how much we have set the load resistance here. How much load resistance we have set it? 25. Yes.
Yes.
Instead of 25, I will increase the load into 30 here. Okay. I'll increase the load into 30. Again, I will switch on the supply here. See here, the current is changed now. Voltage is same, but the current is 1.92. Previously, the current was 2.3.
2.0.
Okay. Now again, you fill the table here now. See here now. The power is very here now. For the load is increased. So the power is 333. 333 we have considered here now. So how the load resistance will increase, like that the current will be decreases over there. Like that here they have added here now. Current is inversely proportional to resistance or not?
Yes.
So here we are increasing the resistance, the current is decreasing.
Yes, sir.
Okay. Next, what I will do? I will set this one into 35. I will set into 35. Again, I will click on the button. See here, 1.64 here now. Again, you fill the table. 1.64. The voltage will become same only. Voltage will become same. So instead of this, you can calculate. So I have started from 0.25 to 35 and find 4 also. Find 40 ohms also. Again, you switch on the supply and fill the table. Fourth reading. Next, 50 ohm I will write directly and switch on the supply and fill the table here. All 5 readings we have taken here. All 5 readings we have taken here now. So you can take more than this also. More than this also you can take 6th reading, automatically it will on. It will add over there. Again, you switch on the supply and fill the table. See here, it will add the 6th one. No, it is not adding. All the tables are filled only. Please switch on the supply first. Get the supply. Okay. Switch on the supply. Next, fill the table. But it is only 5th reading only they have given here now. So up to 5 reading we have calculated here. Will you note down the readings or directly you will leave that one? Anyone have you note down the readings? So you have to write in the power supply. No? Only no need to take all these things. According to your practical manual, VL and this is IL and the W1, W2. These two are calculation part. The calculating you can do that. Any doubts here? This is for the balanced load we have discussed here. Any doubts? Any doubts?
Sir, voltage पण change केलं तर येते का?
We can change the voltage also. No need to worry about that. And by changing the voltage also it will changes.
Okay, sir.
But voltage change होगा तो automatically the current will changes over here. No, we have to fix the voltage. Our main aim is to change the load. By changing the load, the current should be changes over there. So we can keep the load constant by changing here. By keep the, I don't know where it is actually. I will clear the table just a minute. I'll close this one. Okay, again I will click on the perform the simulation here now. See here. See, I have set this one. I will set into 50. I will set the load resistance. Here 100 I have taken here now. I will switch on that one. Okay, I will fill the table here now. For the 100 volt it is over. Okay, next instead of this one I will click 150 volts. Again I will switch on the table. 1.7 here now. 1.1 the then V is directly proportional to R is constant. Now V is directly proportional to I. So voltage increases, then current should also increase here. Now I'll fill the table here. See here, for 150, the VBI will be 150. Current is increased here now. Comparing these two, 1.15. Next is 1.73. Yes.
Yes, sir.
We can increase the voltage also by increasing the voltage. Instead of 150, we can give the 200 also. You can give here now 200. You give the supply, switch on the supply, and fill the table. See here, current is 2.3. Next, you can give the voltage into 250. I will give the 250. I will give here now voltage. Anything you can give here now 250 and switch on the supply. No, I have submitted wrong. No? Okay, 250. Switch on the supply. Again, you fill the table here now. For the 250 volt, how much it is now? 2.8 now here. We can calculate this one here. I am telling, see here, this is the W1 plus W2. W1 is 99 plus 100. How much it is? 199 point means 200. Our aim is to VL IL cos phi. Cos phi equal to 1 only we are considering here now. The first one VL is first root 3 we add here now. Root 3, I will enter root 3. Next, I will show that one. Root 3 into how much voltage is there? Line voltage. This one 100 is there. 100 into the line current is 1.1546988 here now. I will enter that one here. How much it is now? 199 point something is there.
Yes, sir.
199.999 is nothing but approximately equal to 200 only, no? Approximately equal to 200 only. This is the calculated value. This is the measured value. By doing the calculation, you can confirm this one. By doing the calculation, you can confirm this also. Is it clear?
Yes, sir.
Any doubts?
No, sir.
Okay. Similar way, we'll go for the unbalanced load here now. Just click on the unbalanced load. The circuit diagram will be changes here now because the phase voltage will be changes here now. See here, 1 voltmeter we have added for the R phase, another 1 voltmeter for the Y phase, another voltmeter for the third phase we have added here now. So the formula is 3V phase, I phase we have to use. I phase is nothing but this one here. The phase current for the star connection will be same, but the voltage is not same here now. The phase voltage is different. So phase 1 power, phase 2 power, phase 3 power you have to calculate. Then you have to add that one. It should be equal to the W1 plus W2 here. Again here also I will set the 100 volts. Suppose the resistance what I will do, I will set this one as 300 I will set, and this one I will set 290, and this one I will set 250 or 350 I will set that one. Okay, all phases load resistance I have set it different. Hai? Is this different? This one I will set 250. Listen carefully. Okay, 250, 300, 350. Is it clear? So the load is unbalanced here now. R load ko 300 ohm, Y load 250 ohm, then B load it is nothing but 350 ohm is there. 100 volt we have set it for the RY, and VYB the line voltage also they have changed here. VYB instead of this one I will set the line voltage same 100 and 100 here. Okay, and 50 hertz here. I will switch on the supply here. I will switch on the supply. See here, the current is changed here now. This line current, R phase current. The power of R phase is V phase into I phase. This one, 0.2 into 84 we have to calculate. Next, 0.26 into what is this voltage? 66.26 we have to calculate. Next, 0.26 into this one, 92.76 we have to calculate here. Then we have to add all the things here. Then the W1 plus W2 will get equal value here. I will fill the table. You will understand that one here. I will fill the table here. See here, VR equal to this one, Vy equal to this one, Vb. The phase R phase voltage is this one, Y phase voltage is 66, and B phase voltage is 92. The R phase current is 0.28, Y phase current is 0.26, B phase current is 0.26. Is there any difference here? No, much difference. There is no much difference. Same only. Yes. For the star connected, line voltage current is equal to the phase current. We can do that one. Otherwise, you do it. All of you do the calculation. VR into IR equal to how much you will get to calculate that one. Vy into Iy you calculate here. Now Vb into Ib you calculate, and you do addition of all that one. That should be equal to 66.164. You will get that one. Calculated power here. Is it clear? That is the calculated power we are going to call that one. Calculated power. Otherwise, directly the line voltage is 100 here now. The line voltage is 100, root 3 into 100 into this one, 0.27 we can add here. 27 or 28 it is nothing but. Current, line current is changing, na? 0.28 is nothing but 48 something we are going to get. So for the unbalanced load, we have to calculate for each power, each line power, each phase power you have to calculate. Then do the addition of all three here now. VR IR, Vy Iy, Vb Ib. Then your addition of all the things will get the power of 66.16. Then W1 plus W2, addition of these two, how much it will become? Anyone you calculate it? $84.87 into 0.289 plus 66.26 into 0.265 plus 92.769 into 0.265 is nothing but, see here, how much it is? It is showing reverse, huh? Mirror copy it will come. 66.6 we got here now. Yes.
66.67.
66.67 it is got the calculated value, and then you do W1 plus W2. 67.8. So there is no much difference. 66.6 and 67.8. 1 point variation is there. That is also dependent on the line voltage and some errors are there. Is it clear? This is actually unbalanced load is not there for your syllabus. Then also behind the syllabus, content behind the syllabus, like that you can take this one and you can write one separate experiment for this. Content behind the syllabus here. Okay. Next, I will set this one as around 200. I will set this one, and this one I will set as 250 only. This one I will set as 165. Okay, I will change it again here now. Again, I will switch on the supply. I will fill the table here now. See here now, the power is increased because the resistance is decreased here now. The current will vary here now. 0.8 to 0.46 away. Yes, current is increased. So the power is product of current and voltage. So voltage is also the phase voltage is increased here now because current is directly proportional to the voltage here. So like that. So the power again here, instead of 66, how much power it is there now? 145. You can do the calculation. VR IR plus Vy Iy plus Vb Ib equal to W1 plus W2. I'll write the formula here. Based on that, we can do the calculation. VR IR plus VY IY. You multiply this all the things plus VB IB equal to W1 plus W2. By for all readings, you can do calculation here. W1 plus W2. This is the formula we can use for the unbalanced load here. For the unbalanced load. Is it clear? Is it clear?
Yes, sir.
Okay, we'll take the another reading, that is 210. I will take 210 and here this is 180. I will take down 180 and other things you see keep same here. I'll switch on the supply and I will write down here. Little bit increase here. So these two I will not change. Directly this one, instead of 210, I will take 150 here. Again, I will switch on that one. Okay, I will fill the table. See, it is continuously increasing or not? The current is 0.50, 0.04, 502. Like that, little bit changes there here. So next, I will write this one as 120. Other things I will keep constant. 120, I will take that one. Again, I will switch on the supply and fill the table. See here. So these are all 5 readings. You do the calculation and you complete that one here. Is it clear? This is the virtual lab for the 3-phase power measurement by using only 2 wattmeters for the balanced load as well as unbalanced load. I will show the table also. You can take the screenshot and you can note down the values also. Anything for the increasing the voltage we have taken, by increasing the load also you can take that one. Both are available in this video. I will upload this video and you can take that one. Already it is recording. Is it clear? Any doubts? Any doubts in this one?
No, sir.
Can I close this one now? So here by logging to VLab here now, by opening this one, you can take the quiz also here. Quizzes are there here. You can take the quizzes also. Quizzes are there here now. You can test, start your knowledge. See here, actually diagrams are not visible without diagram. The answer you cannot see here now. It is not uploaded, I think, actually. You can take the quizzes and some questions will come, some references they have taken. The references means they have given the book name here now. A Chakrabarti book they have used here now. And even the NPTEL video also they have added here now. You can click on that video and you can see the video of complete explanation also. Yeah, for all the loads they have explained here. Okay, just we have the laptop, computer, PC, even in the mobile also, Google Chrome, you open this one, but it will not open that much clear. In your PC or laptop, you can use this one here. Can I close now? So we will stop here only. So it completes this experiment. We'll continue in the next class.